Gentlemen, straight from the Big Rock Candy Mountain through Hazard Fraud to your shop. 1,200 foot-pounds of torque you. Not to alarm the delicate amongst us, but here are my 3 big brass nuts. And did I mention we were going to test this? I think I did. We were going to test this prior to taking it apart. Yeah, no, fuck that. We'll leave that to the Feels Good in the Hand crew. Lots of those kind of reviews around. We're going to take this apart, get her back together, and then test her. But first, we just got to deburr this and also clean them up real nice so that there's no schmoo in there, what might skew the results. Speaking to the dubious claim of 1,200 foot-pounds nut-busting torque as a non-18-year-old man, that really appeals to me. Sometimes you just need that little extra bit to really bust a proper nut. It's going to be interesting when we get an actual, instead of some fancy scientitious device that was devised to give you the highest torque number possible, we're actually going to have real fasteners and see how much torque this will put on them. Tangentially, the joy in owning a treble of big brass nuts is being able to polish them up. Are we not men? Well, the astute amongst us duly noted that after the fact, I went in and added an operation and bored these out. Reason being, you cannot get a perfect hole by using a twist drill. It doesn't work, especially on something this long. The drill bit goes all cattywampus, ends up in the rhubarb. So what we did, I used a small pilot drill, and then after the fact, added a step. I got my dirty dick beaters around her, and it doesn't feel quite right in the hand. It's very heavy, so that's good, but there's something else going on, and it would be very easy to mistake this for a Milwaukee brand. But there's something funny going on here, and I couldn't figure it out until I started messing around a little bit more. This detent here for the forward reverse, look at this. So the devil is in the details, right? So here's the Milwaukee, and when you go into reverse, the switch is proud of the handle. This one, that right there is neutral, and you have to go further in to actually get it to go into reverse. So that's one of those shitty little things that you wouldn't think anything of it, but all they need is a couple extra millimeters of plastic on there. Even the Hercules from the Hazard Fraud has that feeling, and it's off-putting. It actually is. It's a stupid little thing, but it's off-putting because you think it's in reverse, but it's actually locked. So you got to push it further in. Makes it feel kind of chintzy. As far as the weight, this one is 2.5 kilos, so what's that, 5.5 pounds. And the Milwaukee, comparable Milwaukee here, 2.2 kilos, which is 4.9 minus a bit. So right around 5 pounds for this one, 5.5 pounds for that one. Well, a little less, maybe 4.7, 4.8. So nice and heavy, that's good, but it doesn't, I don't know, we got to get into her to see what's going on, but it doesn't feel right on account of that switch, and this actually feels a little anemic through here. Have you seen those? Well, you've seen them break off right there. I mean, these do take quite a pounding, so that would be suspect to me. We'll get in there. Of note especial, this doesn't have the jungle rod. It doesn't have that stink to her. And I don't know if that's reground material that's been recycled or if it's the mold release, but we do have jeans on a hot Surabaya summer day here. You see this butylene overmolding is starting to stick together already, kind of rotting and melding together. And I got a feeling this is going to be hard to put back together. There you go, some beefy guts there, and pins springing all over the place. Oh, gasket and everything. Let's get into the motor section first, if we can. If we can peel apart those sticky lips. There we go, we're in like sin. Despite the oversight of the stubby nubbin, this is very well made. Beautiful mold making here, and I was wrong on that. Plenty of meat there. very stiff. It just feels, because the gland end is so heavy, I guess it feels like it's got a bad case of the weeble wobbles, but in actual fact it doesn't. PA6, glass fiber reinforced, so nylon reinforced. We'll just have a listen. Yeah, right full of glass fiber. TPR, that's thermoplastic rubber. So that would be SEBS and that other one, SBS, styrene, butyl, butylene, and styrene. So this is thermoplastic. You'll be able to melt this off and reform it, but very well anchored, lots and lots of anchor points. So that's going to mitigate that kind of saggy diaper effect after it gets some grease on it. Very nice part here, surprisingly nice. And when you take these things apart, especially from the hazard fraught, from you know, there's a bit of history there. We all know what they have been selling in the past, so it's surprising to open this up and not have a cockroach fly out at you. But I think we got, well, I don't want to say it too early, but we might have a winner on our hands. Curious little artifact, just a valence. That must be for another model, a tool that has either LEDs to shine onto the work or a battery charge indicator. So this mold here is doing double duty. Whatever contract manufacturing they got going on, they must make this for somebody else as well. At the starting blocks for the Angry Pixie containment device, looks for all the world like "will fuck ye," but it doesn't quite fit. It's just off by a blonde one. Now this looks like chintzy ABS plastic, but when you put an old dirty meat hook on there, she's reasonably rigid. We have a peek here. Most dangerous tool in the shop. Yeah, loaded right full of glass fiber. You can hear it cutting through there. And it's got a little Bunan condom on here, what for vibration dampening. Now, Angry Pixies come in through the red. This is interesting, a Dafont switch. Of course, that French brand name that's actually Chinese. But it's a MOSFET module. It's all built in. All of the other tools, of course, the speed control is all on its own module. And this is actually built into the switch. So Dafont is starting to get into that side of things as well. Massive copper heatsink. That's what we like to see. But where and how is the pulse width modulation to the motor to get the speed control? How is that actually happening? We're going to have a look in here. Interestingly, we haven't seen this before. A single solitary MOSFET, not in a totem pole configuration. And what we have here is a thermistor. Is it a thermistor or a thermostatic fuse? So if it gets too hot, it shuts her down. But this is a SKOOKUM MOSFET. A MOSFET is a metal oxide silicon field effect transistor. That gate, the thing that's letting the pixies go or stopping the pixies, is only 2 nanometers thick. 2 nanometers, by contrast to human hair, is 100,000 nanometers. So there is very little in here preventing the Angry Pixies from running amok. So what normally happens in a driver such as this, now this would be pulse width modulated as well, so wow. What normally happens is this would be in a totem pole configuration because the reversing action is done by physically switching the leads. So we only need 2 of these, and one opens up and allows pixies to turn this, and then when the one closes, the other one opens. No, when the one opens, the other one closes and allows that, because you got current flowing into here, and you stop it dead, it still wants to flow in there. That means the voltage spikes, and that burns stuff out. So what we do is we have another MOSFET that easily opens or closes and allows that to go back from whence it came. But what we're relying on here instead is the body diode in here, part and parcel of the manufacturing process, but a big monster diode in here, what's allowing those voltage spikes to go back to the battery. However, and you look at the documentation, allegedly this has electronic braking, but you cannot do that with only the one MOSFET. It doesn't make a sense. At the risk of springing the entire works, Let's have a wee boo in here. There is some electronicals going on. And the only thing I'm worried about is not the electronicals, but the physical switching. There's always a tiny little spring, and then because it's a snap action, there's some lever action going on there. And if she fucks off on you, I mean, you're hooped. You got to throw the whole thing out. So I do not want to do that, especially prior to testing. I think that's pretty good there. We'll have a nice good look at that. We got the trigger loaded right full to the gunnels of silicon or dielectric grease. And the problem with that is dust is conductive, gets on there, and there's no bellows. There's no bellows. On the higher end tools, you will see a bellows on here, what prevents the ingress of dust. Instead, what we have is a soft little durometer square cross-section O-ring. That'll keep the ball bearings out, but it will not keep the dust out. That's a problem because on the back side of this is a potentiometer. On the back side of this PCB is a potentiometer. It's either a carbon film potentiometer or possibly little tiny traces in a zigzag configuration so that the resistance changes as you move the wiper of this guy in and out. Okay, so then that gets read by the brain box here. This guy is the brains of the operation. Tiny little brain on her, but this is what's controlling. And these are gate drive, no, what are they called? Logic level MOSFETs. So it only takes 4.5 volts to get this to chooch on and off. More than capable. This is more than capable of driving this little MOSFET because essentially the gate on this, it turns into a capacitor. It's a little capacitor. So you just need to charge it up real quick and it'll fire. Now we're probably doing that a couple thousand times a second. You can see all the gold little test points on here, all surface mount. I mean, this is in something that's 1 inch across and 1.5 inches high. It's the world we live in. Incredible. But this is the weak point right here. You can see it's the weak point. It's only got the one MOSFET. Dust is going to get in there as well. So this, although it is a novel solution to a problem, you know, you just buy this off the phone, it's probably not the best solution. If this thing craps out on you, first thing you look for, shit stains on this MOSFET. Pleasantly surprised that the form and fitment of this default switch goes back together, which of course is one of the tough things. Crappy stuff never goes back together proper. This went back together good, but we can see this was not from default. And we got a little bit of an oops here. We got the negative side over here, the positive side over here, or vice versa. And this did not get trimmed, and it is so fucking close to shorting out. So close, within a blonde one of shorting out there. So I'm just going to go ahead and premeditatively clip that off. Perform a little electronical bris here to save us some hassle later on. We're into the motor section now. Nice big beefy brush holders on the commutator card here, and the conductors themselves single strand, so solid conductor but high temp, and then positively affixed with fasteners, not just stake-ons, not just spade connectors, proper ring terminals. That's nice to see. These do, there is the possibility that these loosen off. Easy fix though, however. And we'll just check to see how tight. Yeah, those are on there good and tight. Yeah, this is nice. Oh, also the bearing, not shielded but actually sealed. Now this is an expensive bearing because this turns like a mofo. Spinema things at 30,000 ripums. That means this seal needs to be actually a little bit loose. Needs to be a little bit loose, and we see it is loose. You can turn it quite freely. As that gets up to temperature and spins around, it doesn't wear out, because if the seal is too tight, it'll overheat and burn up. So that's a special bearing there. This is a nice part, man. High end, high fucking end. We got lots of brass in it. Brass because it's goodly conductive. It's also goodly conductive at heat. So bronze, terrible at heat dissipation. Aluminium, of course, it oxidizes and then you get resistance. So this is the best material for that. Nice little features here, man. They're getting her. They're getting her dialed. Look at that. some Celastic on there. Even though they've crimped that braided copper on there, beautiful job. The brushes, they are quite, well, the copper impregnated, but quite a bit harder than we saw on the Hercules drill. And of course there's 4 of them instead of just the 2. Nice constant rate springs here, heavy detent, nice heavy detent, so it's not going to under duress while it's rattling around. Your brushes aren't going to be floating around. This thing's shaping up good. The permanent magnet field on this motor, very nice, bright electroplated. Additional cost, why would they electroplate it? So it doesn't look shitty. Neodymium magnets, we can see the north and south here, very strong. A lot of times they don't use neodymium because it's more expensive. The ring itself isn't that thick, there's not that much meat there, but you can see it is a fairly high cost item, and they have put the effort into making it pretty. That's always a nice touch. Oh, motor armature, nice big com bars. It's already starting to wipe. You see, that's a nice lubricating layer of conductive copper material, carbon material, and then some epoxy schmoo on the stake-ons there at the bottom. That's where it always breaks. That's super nice to see. After my own heart, of course. Directionally agnostic fan. Chooches either direction. Blows the same as much as it sucks. This, though, pretty crusty here on the balancing. Just using a crappy old drill bit. And, yeah, well, you see the results here. Not grinding into those silicon steel bars. We see this in stuff that's like 50 years old. That's the kind of balancing you see. Somebody goes in there with a little drill bit. On the front side of the armature, the motor rotor, the input pinion, 5-lobed, hobbed gear, and hardened. And we see here, as designated by the Z designation, Department of Redundancy Department, it's shielded. This bearing is shielded, not sealed, so nice little touch there. Felt washer for keeping the big chunks out, the big chunks of the brushes out of this, which, you know, abrasives and bearings don't really go together. Other than the throwback to the 70s Hustler Bush style here, you know, not teabag part. These, not loosey-goosey. Lots of coating on there. After the fact, come in with a brush and just put some extra on there. That's always nice to see. Well affixed, nothing rattling loose in there. Despite the warts, not a bad little part. Just when you thought dinosaurs were extinct, metal gearbox. It's like fishing in Madagascar and finding one of them megalodon. No, like a lotopus, megasaurus, one of those things. One of those ones anyway. Metal gearbox and beefy, not aluminium. Doesn't appear to be aluminium. If I had to guess, which I have to, I would say that is die-cast zinc. Still, though, it is metal. And big, beefy fucking ring gear on that. Wow. Look at the size of her. Super, super depthy, girthy. It is sintered metal, however. I mean, look at the size of her. That there is a skookum part. Like, it's fucking beefy, man. Retained by a snap ring, positively affixed. Even has non-chintzy grease in there. Got a nice color to her. Not that, you know, just shit brown that comes with the grinding dust already in it. I'm not convinced that this is actually zinc. So we're going to put a little vinegar on there. See if we can get a slight etch. And if there's big grains, then we know it's zinc, and if there's no grains, it's very likely aluminum. Well, that chooches, we'll get into the business end now. This, holy, beautiful, and fuck me. Now, as a connoisseur of hammers, that is a that is a proper fucker there. Hey, if it's not working, hit it with a hammer, and if that doesn't fix it, the problem's electrical. Look at that, the size of her, totally different design than what we saw in these guys and also in the DeWalt. Look at the flywheel effect here. So we put all the mass on the outside, and it's not just a little T that's turning around. This is, you get that thing spinning a thing around, there is a lot of energy in there. And what happens is when it hits on this guy, so this guy locks up, when it hits on this guy, it has to come up and over these dogs here. And in order to do that, it has to force up against this spring. So this spring-a-thing is beefy. Fuck me. And we can see there's some threads in there with some ball bearings, and that's what actually brings it up and curls it around and then gets it ready for the next hit. That thing, look at, wow, big bearing in there too. Ningbo Guilo bearing, but still nice and big. Just a caged, caged roller, standard deep groove roller bearing there. Forged planetary holder, and looks like, yeah. So those are powder metal gears, but big. Look at the size of them. Bigger is better, especially when you're talking about hammers. Just ask your wife. This thing, in relations to its relations, that is, its provenance, surprisingly skookum, man. This is a forged, this hammer and bit, this is a forged part. Hammer and the anvil, or the anvil rather, forged and then ground, turned, polished, well, not polished, rotary tumbled. I mean, this, and it's stubby. The good thing about stubby is it's stiffer. I know it sounds funny, but if you want super stiff, you gotta go stubby. And this is stubby, man. So this is gonna be super stiff. I can't wait to test this out. I mean, fuck, man, this is the beefiest one I've ever had apart. There's been a few minutes, nothing going on with that. So that's not zinc, that's aluminium. There's no grains starting to show or anything, so it's impervious to vinegar at least. I could do some hydrogen peroxide on there, not hydrogen peroxide, sodium hydroxide, slightly different. One you want to put on, yeah, one you wouldn't want to put on your wounds, that's for sure. But I'm reasonably confident that that is actually aluminium. I was wrong on my first guesstimation. We're getting into the front section, and it's oddly balanced. It's real heavy on the cock end here. What's going on? Nice big. This is great, man. Not only do we have a roller bearing, nice big rollers that takes up lots of thrust. We also have a hardened steel washer, and then the bush in there. There is no mitigation for dust ingress, but on the very rarely do they have any. And we have a hardened steel bushing in here, and it's big, huge, monstrous. Heavier the better. The heavier the tool is when you're talking about impacts, the more oomph you're going to get out of it, because it's essentially one big spin-a-thing and hammer. So that rides on there. You just have a little wedge of grease that lubricates all that. So you will start to see some wear in here, but oh, somebody's unhappy. Better see what's going on. Now, as an entitled white male of a certain age, what an unpleasant surprise it is to have your biases, preconceived ideas, and notions negated by the facts. You know, you peel open that clamshell expecting a Kowloon Chow Hai, and you get something not teabag, much to my chagrin. I had a look at the battery, and this is not as nice as the rest of it, but we'll have our part. And I saw here, cells made in Korea, so maybe Samsung or something like that. Further processing in Taiwan. Now, Taiwan is not mainland China, so I figured, well, maybe they're made in two different spots, but no. Lo and behold, they're both made in Taiwan, not mainland China. Does that have something to do with the quality? Does that have something to do with the fact that there's not that gritty, greasy schmoo all over all the parts? I dare say, yes. Now, as a man, shocking I know, having worked both in Taiwan and mainland China, there is a difference, a quality difference, due mainly to the attitude of the workers in the factories. Zero fucks given, for the most part, in mainland China on the heavy industrial manufacturing. Basically, the least they can get by with is what they're going to get by with. But in Taiwan, they're higher up the value proposition, so more quality stuff going on there. But we do get, as we see, I mean, visibly better quality coming out of Taiwan than mainland China. That's a very rigid surmounting. Nice ribbing in there. That's a good part. No stank to her. No stank to her. Is it the country of origin? Or is it just they use reground stuff in all their injection molding? I don't know what that stink is, but as soon as you walk into that store, you know exactly what it is. Yeah. No confuser on there at all, no charge controller, no overcurrent protection. That, I assume, is all done in the switch or not done at all. Cute little arrangement here for the lights, some 3mm LEDs, chintzy. Push the button, it goes to Zener diodes. So if the voltage is below the Zener diode threshold, it won't reverse, so you don't get any lights on. No microcontrollers at all in there. This is cute, the appliant or compliant overmolding. It's got ribs in it that engage, that index in the ribs in the casement, so it becomes one piece. Very clever, and as far as I can tell, right off the hop, LG cells. Nice. As a counterpoint, we look at the charger. Made in mainland China, PR China. The sniff test. Oh, yeah. That's got the cancer. This stuff, no scent at all. This, stanky. What the F, yo? We're going to have wow, it'd be interesting. We're going to take this apart so we can see the difference. Obviously made in a different factory. Rebadged. Oh boy, oh boy. Sadly, disappointingly, uncrusty. The ABS plastique, still pretty rigid. Waffle pattern on the ejection pins on the parts, flat on the flat parts, and then retention here on the parts that are chamfered a little bit. As far as the board goes, nicely done. Nothing tombstoned. Little feature here. This appears to be some sort of spark gap dissipative protection, and switch mode power supply. Surprisingly uncrusty. Lots of Celastic to keeping everything in there good. Nice big beefy components. They even got isolation slots routed in there. Nothing wrong with that. Well, it turns out I thought I was wrong, but I was mistaken. Saw something neat and jumped all over it. That's actually an artifact of having not installed the input choke here. Some capacitors and chokes on the input side. Of course, you design this and start paring it down, but I would have absolutely no qualms about leaving this plugged in. It looks well built, and yeah, even the little touch of Celastic on this big beefy cap. Lots of mechanical protection for this getting tossed around in the back of your truck or whatever. Because it doesn't always live. The charger goes where the gun goes, so it doesn't always live in a nice, clean, warm shop. Freshly washed and rinsed out of the back of the tank, we are going to put my big brass nut in there. I have a feeling this thing will shoot at 300, 350 foot-pounds, backing off an actual bolt in an actual nut in actual fact. Now, that 1,200 foot-pounds in reverse breakaway nut busting torque, is that an out-and-out lie? Yes and no. No, because the benchmark is designed, the test that they are using is designed, and we can see it on other channels, to get the most torque, the highest torque number. So they're going ahead and using the most rigid, most stout test mechanism they can and tuning it so that they get the highest number, so they can say, look, buy this one, it's the highest number, science proves it. The problem with that is it's not real life. It's not an actual bolt. It's the fucking thing is 1.25 inches fine thread. New grease every time. New all clean, So, in this case, we are going to use the hydraulic torque wrench, which has been used in industry for the past 30, 40, 50 years. Any pipeline, any crane, any structure, any big civil engineering, anything with a bolted connection has been put together and torqued with one of these. Good enough for heavy industry, good enough for this shop. So 300 foot-pounds is 307 is 1,600. I say we go to 2,000. That'll bring us up to 385, just to make sure we're not able to take that apart. That's a 5/8 course bolt, which of course should be torqued to 250, 220, something like that. So way over torque on this. If it, by some miraculous chance, happens to break this off, loosen it, then we'll have to go to the next size up fastener. There, we're coming up. 2,000. I dropped off the pressure. We're at 385 foot-pounds. We'll put her in the big boy vise. There we go. We're at 2,000 psi on the torque wrench. That's for 385. 385 at a brand new impact heavy wall. Impact socket 15/16. Chrome molybdenum. And I feel like I should engage some safety squints. Contact. Holy shit. Got more chooch than I give her credit for. Wow. 2,600 is 500 foot-pounds, so we'll go to 2,600. If she'll suffer 2,600. Remember, that's way over torque for that grade and size of fastener. And we are there. Just make sure. Yeah, 2,600. That's 500 foot-pounds. Okay, 500 foot-pounds. I wouldn't have fucking believed it. I wouldn't have believed it. Okay, well, nothing for it than to try again. Oh, so close. That there is 3,000. We'll give that a go. 3,000 pissies on the gauge is 578 foot-pounds. Plenty. Again, way over torqued the fastener. Probably stretched her out. Here's blood in your eye. Holy fuck. Well, I don't know what to tell you. The gun's got some fucking jam. We need a bigger fastener. 2 words, what don't belong in the same sentence together. Harbor Freight and SKOOKUM. The mechanicals of this thing, pleasantly surprised. They're beautiful, beefy. The only thing is the switch mechanism with the built-in MOSFET and all the controller right in here. Yeah, big. Yeah. If you have problems with this, it's gonna be that MOSFET. So, I never would have guessed that this would put out 500 plus foot-pounds of actual torque. Not make-believe torque, not marketeering torque, but actual 500 foot-pounds. We got to make a bigger jig in order to test these properly. So, I got some fasteners on the way. Until then, thanks for watching. Keep your dick in a vise.